Good afternoon, everyone. Uh, we'll continue our
Okay.
and we'll be considering complex numbers. Because in some uh, in some calculations in electrical engineering, especially when we talk about AC, you have to use complex numbers. You know, the resistance is usually the real part. Then the capacitance and the inductance, they are usually represented as imaginary part. And when we talk about power too, we have S is equal to P plus JQ. The reactive part of the power is imaginary part of the power. So those are the reasons why we need to go into complex numbers in this course. So that's what we are going to be dealing with today. It is going to be a very brief one. So in the past, before now, when you want to find the square root of a negative number, there is no solution for it in the past. But later, mathematicians came around and what they did was they opened up a new series entirely about finding the square root of a negative number. So that is why, because the numbers we deal with before then was only real numbers. But now, when they wanted to solve the square root of -1 or of a negative number, they came about what is called imaginary number. So I said once upon a time, if you want to find the square root of -1, you cannot get a real solution. They will tell you error. Just like now that you cannot divide a number by 0. In future, somebody may be able to come up with a solution to that. But then you cannot find the square root of a negative number. But later came up with an idea. So that is why we'll be studying this topic today. So, come in, please. Okay. When we talk about numbers, we have different kind of numbers. We have the natural number, which are 1, 2, 3, 4 to infinity. Then we have whole numbers that are not fraction. They are not fraction. So those are whole numbers. And we have integers. When we talk about natural, we started from 1. So, but integers, it also includes the negative numbers, but they are whole numbers. Then we have rational numbers, and those are numbers that can be written in fraction. It can be written as 1/2, 1/3, all those things. Those are rational numbers. Then we have irrational numbers that cannot be written as fraction. Example is pi. 22/7, when you divide it, it has a very long value. I think pi is the longest value that you can ever get. So we have real numbers. All these ones that we have discussed, they are real numbers. They are real numbers. Then we have pure imaginary numbers. Those are purely imaginary. They don't contain any real part. If you want to say they contain real parts, maybe you can say 0 plus what they are, but usually they don't have any real part. Those are pure imaginary numbers. So, and you can also have a mix of both. Imaginary, you can have the real and the imaginary number. You can have them together. So since all numbers belong to the complex number, all numbers can be classified as complex. That's what I just said. You can classify them as everything. You can classify as complex. What you need to do to a real number to make it complex is to add an imaginary part. That is 0 multiplied by I, because we usually represent I is usually what we use to represent the imaginary part. So if you have a purely imaginary number, all you need to do is to add 0 to the imaginary number. or subtract 0 from it. So that's why we say a complex number is a number that has a real part added or subtracted from an imaginary part. So that is the simple definition of complex number. So usually math is used to explain our universe. When a recurring phenomenon is seen and can't be explained by our present mathematics, I said that the other time, we develop new mathematical systems that can be used to explain those things. And that's what happened in the case of imaginary number. In the real number system, we can't take the square root of negatives. You cannot take the square root of negative. If you press your calculator, find the square root of minus, you say, okay, I want to find the square root of -1. Your calculator is going to give you mathematical error. But what you can do is that you can solve with your hand, because they have been proven proof that you can use in getting the square root of a negative number. But in the past, you cannot get it, even while you want to prove. So in the real number system, we can't take the square root of negatives. Therefore, the complex number system was created. So complex number revolutionized the computer graphics. It changed computer graphics. Okay, it changed the way, because when the building block of graphics is numbers. You plot numbers with each other. By the time you get to, I think maybe next level, or maybe, have you done computer graphics? I think that one will be treated in that course if you have not done. So if you want to read more about how we got imaginary numbers, this link is here. You will see by the end of this class, I think this lecture notes will be available on the LMS platform. So in the set of real numbers, negative numbers do not have square roots. We have been able to agree on that. Then imaginary numbers were invented so that negative numbers would have square roots and certain equations would have solution, because in the past there were no solution to some mathematical expressions. So these numbers were devised using an imaginary unit I. So when you see I standing beside a number, it means that number is imaginary number. So, and one of the rules is that I is equal to square root of -1. Please take note of that. The square root of -1 is I, or I is the square root of -1, either of the two. You can say I is equal to minus square root of 1, or you can say square root of -1 is equal to I, either of the two, because we have an equal to in the middle. So you can bring this here or bring this here. So please take note of that. It's very important, because we are going to use it very well. So imaginary numbers consist of all numbers, say BI, assuming it's BI. You know, when we start with A, if A is the real number, then BI is the imaginary number, where B is a real number and I is imaginary unit, with the property that I squared is equal to 1. Please take note of that too. I squared is equal to -1. I squared is -1. We have said that I is root of -1, but I squared is -1. It's very important. So the first 4 powers of I establish an important pattern that you must memorize. I will show you the stuff now. As I said, I raised to power 1 is equal to I. You must know that. You must also know that I squared is equal to -1. I squared is -1. I raised to cube, I cube is what? -I. You should take note of that. And I raised to power 4 is equal to 1. These 4 expressions form the building block for everything, whether you are multiplying or subtracting or something. Somebody is disturbing us, please. You should try and see if you are the one, and mute yourself. Somebody is playing a game there, please. So I said I raised to power 3 is minus I. So these are the powers of I. And you should take note of this. When you are dividing by exponent, please hold on, please. Afis, you are disturbing us. Ishola Afis, you are disturbing us, please. Okay, let's continue, please. So, when you divide the exponents by 4, so if you have a remainder that is, when you have no remainder, that is, the answer is 1. But when the remainder is 1, your answer is I. When the remainder is 1, your answer is I. When you have a remainder of 2, your answer is minus 1. And when you have a remainder of 3, your answer is minus 4. That is minus I. That is when you divide by 4. You get what I'm trying to say. The next slide. Okay, let's look at this. If you are told to find I raised to power 23, how do you get that? What you simply do is that you take your 23, this 23, you divide it by 4. If you divide 23 by 4, what do you have? 23 divided by 4 will give us 5. You have 5, and you have a remainder of what? Of 3. Am I right? You have 5, remainder 3, when you divide 24 by 3. So let's go back to the last slide and see what our answer is going to be. I raised to power 23. We have a, take note that we have a remainder of 3. We have a remainder of 3. We said if we have a remainder of 3, our answer is what? Minus I. So in this case, if you are told to find I raised to power 23, your answer is minus I. Minus I. Let's try for 2006. So if you want to do for 2006, you divide it by 4. So you are going to get, you are going to have a remainder of what? You have 501. So when you multiply 501 by 4, 501 times 4 is going to give you
remainder 2.
Remainder 2. So if you have remainder 2, what's the I going to be? When you have remainder 2, it's going to be what? Minus 1.
Minus 1.
Yeah. So you can you can check the rest after the class to see your answer. Is that clear? Okay. So you can see this is minus 1, minus I, this is minus 1, this is I, and this 1. Please go through it if there is any mistake. Okay, so I want you to populate this table. You get it? Try and populate it later. These are the powers, and put the exponents here. Then what they are, if you simplify them, you should put them. I'm coming, please. Okay. So express these numbers in terms of I. So if you have minus 5, what is it going to be? We said that this minus 5, can rewrite minus 5 as root of minus 1 times root 5. We can do that. And we already concluded that root of minus 1 is equal to I. Root of minus 1, I. So our answer would be what? I into root of 5. That's what our answer is going to be. Then if you want to write minus root of minus 7, you already know that we can break this minus 7 into roots. Minus 1 multiplied by root 7. If you do that, it's going to give you this. By the time you do it will be 11. So you can try this. If you look at number 6, what is it going to be? It's going to be minus, it's going to be high root 7. Next one is going to be what? Minus 6 high. You go and lay your hands on it and see if they are correct. Then the next one will be 4i into root 10. So now we want to do multiplication. We want to look at multiplication. So if you multiply 7i by 2, what you need to do is just to multiply only the real part by the 2. So if you multiply 47 by 2, you are going to get 94. So when you get 94, you just put the high there, 94 high. So, and that's why you have this answer, 94 high. So the next one is this. We want to solve this. So how do we solve this now? We have 2 high, and we have root minus 5. So we are going to break it down into this, minus 1 times 5. And we know that minus 1, minus root of minus 1 is high. So the high will come out like this. So when you multiply high by high, what will it give you? It will give you I squared. When it gives you I squared, what is I squared? We know that our I squared is what? Minus 1. I squared is minus 1. So it will be minus 2 multiplied by root 5. You can see minus 2 multiplied by root 5. So that's the answer. So you can also solve these. Bring out the minus 1 of this. Bring out the minus 1 of this. So when you bring them out, you're going to give minus, this one is because there's a negative here. Negative here is there. So to give you minus high root 3 multiplied by root high. So when you do that, you have to square the high. So what is minus I squared? What is minus I squared? So this is what you are going to have. You are going to have I squared. What we have done so far is to define what imaginary unit is. I will say it's denoted by I. I is what? Root minus 1. And we also said I squared is equal to minus 1. Can you speak to the person that is disturbing us? And you will recall that we also said something about this, about I squared being minus 1, I cubed being minus I, and I raised to the power 4 being 1. Those things are very important when you are, although these days you have a calculator you can use to do it, but when they give you work to do and you have no calculator, then you have to know these things by heart. Okay, let's continue. So and we define complex number as a plus bi, where the bi is the imaginary part and the a is the real part. So the complex numbers consist of all sums a plus bi. A can be any value of real number, b can be any value of real number. Where a and b are real numbers, you can see that, and I is the imaginary unit. So the real part is a and the imaginary part is bi. So you can see. So we want to deal with addition. When we add two imaginary numbers, what do we have? When we want to add 7 high and 9 high, all you need to add is to add 7 to 9. When you add 7 to 9, you get 16. So your answer is 16 high. Your answer is 16 high. Okay. So let's move on. When you have this kind of expression. You open bracket minus 5 plus 6i, close bracket, plus you open another bracket 2 minus 11i, you close the bracket. What do we get? In this case, what you do is you add the real part and you add the imaginary part separately. So that is, you add minus 5 to 2 and you add plus 6i to minus 11i. So when you add minus 5 to 2, you are going to get minus 3. You see, you add those two. And when you add 6i to minus 11i, you get minus 5i. And that's how you get your answer. So let's do another one. If you are going to do this, 2 plus 3i minus 4 plus 2i. Please take note of the negative sign outside this bracket. It's going to multiply all this. So you are now going to have 2 plus 3i minus 4 minus 2i. Please take note. So this is what you are going to have. Don't be carried away because of this negative. So when you do that, you are going to have minus 2 plus I. So we want to see how we can multiply and divide complex numbers. How you can divide, how you can multiply and divide complex numbers. Okay. So to multiply 3i and 4i, how do we do that? And what is 7i squared? How do we get that? So if you look at it, when you multiply 3 and 4, it's going to give you 12. I and I is I squared. And what did we say I squared is? We said our I squared is minus 1. So that means our answer for the first one is 12. You can see minus 12. So when we say 7i squared, what is 7 squared? 7 squared is 49. And I squared, you put I squared behind it. So, and based on our previous experience, I squared is minus 1. So minus 1 times 7 squared. So that means 49 times minus 1, which should give you minus 49. So if you are going to try the number 3, what is it going to give us? Is there anybody, if you know the answer, you can raise up your hand, I will call you. Anybody? Number 3. Gideon, what's the answer?
84.
84. Any contrary answer? Any contrary?
Minus 84i.
Minus 84i. Okay, can you mute yourself, please? Thank you. Mute yourself, please. Thank you. So let's see who is correct. Mute yourself, please. So somebody said minus 84i squared. And when you have I squared is minus 1. And minus 1 times minus 84. What does it give you? 84. So the answer is 84. So I think Aremu said 84. Thank you for that. So the second one, who can tell me? Okay, let me see. Who can tell me what second one is? Let me see if I can call somebody. Yeah. Okay. Is there anybody interested in answering it? Minus 11 squared. Gideon, what's the answer?
11.
11. No. Are you sure?
1 to 1.
Yeah.
Okay. Who said 1 to 1?
Different.
Israel. Okay. Let's see the correct answer. I'm sure Israel must be correct. Can you see? Okay. Minus 121.
1 to 1.
All right.
Minus 121.
Yeah, thank you. All right. Now, we want to see how to go about this kind of multiplication. in this case, what you do is the normal way you expand your bracket. You multiply 4 by 7. Then you multiply 4 by 2i. You also multiply 3i by 7, and you multiply 3i by 2i. So let's see how to do that. So 4 times 7 is what? 28. Then 4 times 2i will give us what? 8i. Then 3i times 7 is 21i. Then 3i times 2i is 6i squared. Now, we are going to now apply two things that we have taught, we have learned. You apply your addition that we have just learned, and you apply the exponential that we treated previously. So what are you going to add? 28 plus, there's nothing to add 28 to, so you write 28. And you had 8i plus 21i. When you had 8i plus 21i, what does it give you? It gives you 29i. And when we want to express our 6i squared, our I squared is -1. So it will be 6 multiplied by -1. See, this is it, 6 multiplied by -1. So when you multiply 6 by -1, it's going to give you -6. So you remove -6 from 28. It's going to give you 22. Am I right? So it's going to be 22 plus 29i. 22 plus 29i. Okay. All right. Somebody is saying there is a connection problem. We are presently recording this lecture, and you have it after the class. All right. So please lay your hands on this and tell me what your answer is. Don't use your calculator, please. I know you have calculators there. Don't use it. Use your hand to solve. What would the answer be? What's the answer?
-6. Sorry, sir.
Okay.
-4.
Yeah, okay, -4. Let's see.
Sir,
Okay, I'm coming. Who else? Someone is reading off his hand. You can come in
No.
and what do you say?
can I check? 16 plus 17i.
16.
What did you say?
16 plus 17i.
16 plus 17i. Let's see. We're going to see
So
that.
I'll change my answer. 16.
16. Okay.
Yes, sir.
Let's see. All right. The window is closed now. Let's see the answer. Can you mute yourself, please? Thanks. So when you open up bracket, you get this. When you simplify, you get this. Simplify further, you get this. And your final answer, you get 16 plus 17i. And I have somebody that got it. So thank you for that. That means you are following the class. All right. Now let's go on. So what is the answer to this? You can type it in the chat room. If you have the answer, write it in the chat room and let me see. Type it in the chat room. What's the answer? Nobody knows it. Nobody knows it. Okay. Gideon, do you have the answer?
Yes, sir. 74.
74. Okay. 74. Aziz, what's the answer? Ishola Aziz. He's not here. He's just open.
I'm solving it. I'm solving it.
Okay. Miriam,
Sir,
what's the answer?
74, sir.
74. Okay. Let's see. 74, 72. Good. 74. Okay. Let's see. Let's call someone else. Let's see the last person that. 4. Ayola Steven. What's the answer? Ayola Steven. What's the answer? Okay. Ayola Steven is not here. Maybe his network is bad or he's busy doing something. All right, let's go on. So you have 25 minus 35i plus 35i minus 49i squared. So that cancels out. So you have this, and the final answer is what? 74. So the person that says 72, where did you donate your 2 to? Okay, you tried, but if you were in the class, I would have been able to see where you made a mistake, and but based on this, you can see where the mistake you made is, and you can correct it. All right, let's continue. So there is what we call conjugate. Conjugate. I know if you have done sorts, you will have learned about what they call conjugate. There's something called conjugate too also in sorts when you are doing sorts. Okay. So the conjugate of A plus B high is A minus B high. The conjugate of A minus B high is A plus B high. By inspection, you will see that when you want to write the conjugate, the only thing that changes is the sign attached to the imaginary part. Sign attached to the imaginary part. You can see this positive is now negative and this negative is now positive. Why are we learning about conjugates? When we want to divide, this is what we are going to use in division, the conjugate. You multiply the denominator and the numerator by the conjugate of the denominator. That's what we usually do. Okay, let's continue. So if we want to find the conjugate of 3 plus 4i, it's going to give us what? 3 minus 4i. So the conjugate of minus 4 minus 7i is what? It's minus 4 plus 7i. So the conjugate of 5i is what? Minus 5i. And the conjugate of 6 is what? What's the conjugate of 6? Anybody? Conjugate of 6?
6.
Conjugate of 6 is 6. Thank you. That means you are following us. Why is conjugate of 6 6? Conjugate of 6 is 6 because 6 plus 0i is the same thing as 6 minus 0i. So that is why. All right. Let's continue. So we now want to divide. So we are asked to divide minus 5 plus 9i by 1 minus I. When you are given this kind of expression to solve, what you need to do is to multiply the denominator and the numerator by the conjugate of the denominator. In this case, our denominator is 1 minus I. Our denominator is 1 minus I. So we are going to multiply both numerator and denominator by 1 plus I. That is the conjugate of the numerator, the denominator, sorry. So if you have that, you have this, you see. So we are multiplying by what? 1 plus I. You multiply the numerator and the denominator by 1 plus I. And that 1 plus I is the what? Conjugate of 1 minus I. That is the conjugate of the denominator. So when we have done multiplication just now, when you do it very well, you are going to get this expression. And when you get this expression, you know that your I squared is minus 1, I squared is minus 1. So if you solve further, you are going to get this. You are going to get this. So you can do this further. You know that minus I squared is what? Minus 1. So a minus 1 times minus is 1. So 1 plus 1 is 2. So then you still have this. So when you divide this, you are going to get minus 7 plus 2i. That is how to do division. That is how to do division. So I want you to lay your hands on this and tell me what the answer is going to be. I think this is the last thing we are going to do for today. What's the answer, please? Is the class rep in the class? Matthew Adegboyega, what's the answer? I'm waiting for you. Matthew Adegboyega. Gideon, what's the answer?
21 over 34 plus 34i.
21
over 34 plus 34i. Plus 1 over 34i, rather. Sorry, sir. Plus 1 over 34i.
This your answer is okay. We see if you get it. Who else want to try?
Oh.
Is Miriam trying?
Sorry, sir.
Okay, I'm listening.
Oh, sorry, sir. Is minus 9 over 34 minus 19 over 34i.
Okay, that's interesting. That's interesting. Who else want to try before we see what the answer is? Okay, nobody is trying again. Okay, let's move on and see. Okay. What's the conjugate? The conjugate is obviously 3 minus 5i.
3 minus 5i.
Yeah. So the next thing is to expand. If you expand, you are going to get this expression. 6 minus 10i minus 9i plus 15i squared. 9 minus 15i plus 15i minus 25i squared. If you simplify further, you are going to get this. And you are going to get the final answer as minus 9 minus 19i divided by 34. So where did you get it wrong? You can look through, you can walk back with this solution and see where you got it wrong.
Sir, was correct.
Okay. So we are come to the end of the class. So I will stop recording now.